Today we're going to look at rational word problems. We've previously looked at rational equations. We've previously looked at rational functions. All of these are involving x in the denominator. Today we're going to generate an equation through a word problem where x is in the denominator based on the directions of a word problem. I want to discuss the 5-step process that I would like to see for all word problems from here on out. We haven't done many word problems this year, but we will increase with that. So the first thing I would like to see is a definition of the variable. We need to say x equals whatever to define that variable. We're then going to write an equation or an inequality without the variable. So I need an equation that does not involve x. Third, an equation with the variable. Fourth, we're going to solve for the variable. And the final step is we are going to interpret the solution. We're going to tell the viewer of our problem what the answer is. In this first problem, how much pure acid must be added to 50 milliliters of 35% acid solution to produce a mixture that is 75% acid? Oftentimes the question is going to be the definition of our variable. So the first point here, if this was a 5-point question, would be, can you define the variable? So x, what does x equal here? X is going to equal the amount of pure acid. And that's going to be in milliliters. And this is the amount that's been added. All right, so how much acid do we need to add? The second thing, and oftentimes this is probably the hardest step, the second thing we need to do is we need to write an equation without the variable. So the equation without the variable here, and this is going to vary depending on every problem, but the problem here says that the concentration of acid is going to be equivalent to the milliliters of acid over the milliliters of the mixture. Now we need to substitute in, and in this substitution we can include an equation with the variable. So we can now have x. So the concentration of the acid that is desirable for us is 75%, 0.75. And the milliliters of acid will be the amount that we add x plus the amount that was previously in there. And the amount that was previously in there is going to be 35% of the 50 milliliters. Divide that by the milliliters of the mixture. Well, the mixture is going to be the amount that we add plus the total 50 milliliters that we previously had. This equation comes based on the blue equation of the concentration of the acid based on the milliliters of acid divided by the milliliters of mixture. We're now going to solve this. We can solve this by cross-multiplying. We can solve this by creating a common denominator. I don't really have a preference as to how you solve this equation. That's really on you, and that'll go back to what we've been doing. But what we will get is x equals 80. That's our fourth point there. The final and fifth point is interpret our solution. The problem did not say solve for x. The problem said how much pure acid. So our final point will be awarded for saying 80 milliliters of pure acid needs to be added. We need to include units there, which we did with the 80 milliliters. A second problem that we're going to get into here today, and feel free to pause this to write it down. A canning company packages tomato juice in 2-liter cylindrical cans. Find the radius of the cans if the cans have a surface area of 1,000 cubic centimeters. I know a lot of times these word problems seem irrelevant, but you certainly could see how a company would like to maximize its profit by reducing can size, the surface area, how that matters for a certain company. So we need to take into consideration here a couple things that are relevant for us. First, what is our unknown? We need to find the radius of the cans. So we're going to define that unknown to be x equals the radius of the cans. In here, it's important to understand what 1 liter equals. 1 liter equal to 1,000 cubic centimeters. So I think that'll tell us that the radius of this can is going to be a linear unit of centimeters. Here we need to write any equation that might be relevant without x, without our desired variable. I think there's two. I think one is going to be volume. A volume of a cylindrical can is going to be the area of its base, which is pi r squared, times the height between those two bases. So here's my h, here's my r, and that's going to be the volume. Another relevant equation here for us, in this case we actually have two, is going to be the surface area. And the surface area of a cylindrical can, again, we could figure this out, or we could go to the internet, or we could go to our textbook. We could go to a lot of resources here. But the surface area is going to be the surface area of the top and the bottom, which is two circles, 2 pi r squared, plus the surface area of the side, which if we laid that out would look like a rectangle with a dimension of 2 pi r for the length and h for the width. We could Google that, or we could figure that out as you wish. We're now going to substitute in anything that we know. The volume here we're going to substitute in to be 2,000 centimeters cubed, or 2,000 liters. Pi, r is going to represent x, and h is still unknown. Surface area would be 1,000 cubic centimeters equals 2 pi x squared plus 2 pi x times h. Unfortunately here we have two variables in each equation, x and h. But because we have two equations, we're able to solve those through a system of equations. A system of equations can be solved two ways. A system of equations could be solved through substitution or through elimination. I would suggest we do this by elimination. Let's isolate this h and say that h equals 2,000 divided by pi x squared. We're now going to substitute this 2,000 pi x squared in for h. We'll have 1,000 equals 2 pi x squared plus 2 pi x times 2,000 over pi x squared. If we simplify, we have 1,000 equals 2 pi x squared plus the pi's are going to cancel. One set of x is going to cancel. The 2 times the 2,000 in the numerator over an x. Here we see our rational equation with x in the denominator. I'm going to leave it up to you right now to determine how to solve that equation, including using your graphing calculator. We'll finish that problem up tomorrow to start class, but I really want you to take into account here the 5 things that I'm looking for. A definition of our variable, an equation without x, an equation with x. We will then solve for x, x equals, and then we will interpret our answer. Those are the 5 points I'm looking for in any word problem.